All right.
All right, hello. Welcome to the Synthetic Native podcast. I'm Thomas Grice, and I have a really special guest with me here today. His name is Eric Neuman. I'll go ahead and let you introduce yourself, Eric.
Hey guys, I'm Eric Neuman. I'm the director of VR tools over at Digital Domain. Formerly, I was the founder of a company called Sprawly, and then Digital Domain acquired us. So I'm kind of doing over there what I was doing before, but now with a way bigger budget and a sweet team. My background is pretty varied. I've worked at NASA. I've written software for the government of Belize. I've kind of been all up and over the place. I've been coding for 20 years. And I guess what pertains to this conversation tonight is that I've been working almost exclusively in VR for the last 3 years and designing a lot of experiences around not making people puke their guts out. And part of what aids me in that is that I did study cognitive science as a part of my AI minor at college at Case Western. So I do have sort of a multi-varied background here, tech and sort of like wetware, hardware and wetware, and software all together.
Yeah, it seems like a killer combination. So, yeah, I guess we can go right into it. Like, if for people maybe who don't have any idea what VR motion sickness even is, I'm sure most people know what motion sickness is, but if you could just like take a stab at explaining like what is VR simulator sickness.
Totally. So in the simplest possible way to explain it, it's motion sickness that's caused, ironically, by a lack of motion. The way that I usually explain VR sickness to people is that it's caused. Well, should I talk about what it's caused by, or should I just explain what it actually is?
Yeah, like kind of like what I mean. Most people know that I get like if you read in a car or certain situations, you'll get motion sickness and you kind of just feel like sick. So it's that pretty much that feeling, but it can be a lot worse. I guess you could talk about like if there's anything I missed there. You could talk about that. Maybe if you've seen any like examples of it with users or with yourself, and then yeah, more like how is it caused? I know on a high level it's sort of there's a disconnect between your inner ear vestibulo-ocular cis reaction and what you're seeing because your eyes are telling you you're moving, but your ear isn't. So I'm sure you can put it a little bit more eloquently than me, maybe. But yeah, that just all the whole spiel would be cool.
Cool, yeah. So ultimately, what you need to know is you need to think about what's called sensation and perception, right? Which is the study of the way that your body takes in and then processes information. And so when you're in VR, what's going on is that you have these lovely, amazing bleeding edge goggles that are feeding your eyes what essentially amount to lies, right? The goggles are telling you that something is happening that is not. And the entire first 2 or maybe 3 years of the history of VR, this modern history, this sort of like reboot of VR, were entirely dedicated to what's called presence, right? And if you notice, if you've been paying attention to the VR conversation 2-3 years ago, we were all talking about presence all the time. I mean, we were obsessed with it. And now that conversation has kind of fallen off. And that's because we basically hit it, right? So presence means that you have a level of graphical and motion fidelity that is so realistic that your brain thinks you're there. You think that you are in this thing. And at a neurological level, this is much more than just like a neat trick. Your brain really thinks you're there. Like for example, when you form memories playing a video game or watching a movie, you form memories of playing a game or watching a movie. But when you form memories in VR, you form memories of being in the place that you are, right? People talk about like, oh, hey, there's this level in this game that I put my guy in. But when you talk about something in VR, you say like, I went to this place. And when you go back there, you end up having this feeling of like, I'm back. Anyway, so what this means is that the lies that the goggles are sending to your eyeballs are extremely convincing. Your brain does not know visually that it's not real. But your eyes are kind of the only part of your body that we're really lying to. We are increasingly starting to get audio to be realistic and to be convincing. The Oculus has its built-in headset, which actually has speakers all the way around, tons of speakers, I think 7 in each headphone, so that we can hit your ear from all different directions. But we're not doing anything to your body, and we're definitely not doing anything to what's critical in this situation is your inner ear, your vestibular system. So again, let's talk about sensation and perception. Inside of your inner ear is this thing called the vestibular canal. And it's actually vestibular canals. And this little thing is incredible. If people are out there are looking or in front of a computer, if you have your phone, I would really recommend you go and just look up a picture of what this thing looks like. What's incredible about it is that it looks almost exactly like what a multi-axis accelerometer looks like. It looks like 3 C-shaped tubes that intersect. And inside of these tubes are a tiny little amount of liquid inside of each one. And lining the inside of the tubes are these like literally borderline microscopic hairs that are called cilia. And cilia they're like whiskers, right? They're little teeny tiny whiskers, and every single one of them is connected to a nerve. And that nerve is capable of feeding information about whether it's been triggered, whether the liquid has sloshed past it. And so what this does is your vestibular canals, your inner ear, it measures, and I'm going to be very, very explicit about this, it measures acceleration. A lot of people get mixed up about this. They think that their inner ear measures motion, right? What we talk about motion sickness. If you're in the car, we say you're getting sick because the car is moving. But the reality is that your ear doesn't measure motion. If you're inside of a car and it's moving and it's perfectly steady, your ear is not receiving any motion data at all whatsoever. Your ear only is capable of measuring acceleration. So I'm just sort of going to keep going with this. The difference between acceleration and motion is that acceleration is the change in motion. Specifically, it is the rate of change of motion. So, for example, if you are moving in a straight line and you're moving at a constant speed, there is no acceleration there. It is exactly the same physically. The forces acting on your body are identical to if you were standing still. But if you are going in that same straight line and you speed up, you are now accelerating. So you're experiencing force, right? Force equals mass times acceleration. So you experience this amount of force, which varies the amount of acceleration that you have. Now, as long as we're talking about this physics, what's interesting is that acceleration actually also applies to direction. It's not just speed. So if you're going in your straight line and you go at a constant speed, but you change direction, you turn, that actually is also an acceleration. I slightly misspoke before. What acceleration really is it is a change in the rate of your velocity. Mm-hmm. And velocity is motion in a direction. So if you change your speed or your direction, that counts as acceleration. Okay,
right.
So let's
there's like a vector to it, right?
Exactly. Any alteration to your vector is acceleration. That's precisely what it is.
So I think this is a good point to seg. If there's something you're really critical you're about to say that I'm interrupting you, please say it. But I was going to ask you, because I think this is a good segue, which types of experiences cause this the most? Because I know that for me, if it's just like static sitting there type of VR experience, like I'm fine. But the example that comes to mind recently, at least for me, is I believe it's called Echo Arena. It's like a free game for Oculus. Maybe you've heard of it. And you're almost in like it reminds me of Blitzball from Final Fantasy X. But you're like in like an arena. You're floating around and you're like throwing a ball through hoops. But it's like a very high velocity. Like your acceleration changes a lot in the game. That made me feel very ill.
It's actually based on the main plot device in the story called Ender's Game. I don't know if you've read that.
Yeah.
That game is actually like basically somebody just took the game from Ender's Game and made it real in a video game. But yeah, so let's use this as an example. right? So if you're in that game, I bet you, if you were just floating freely through space, not altering your direction, you wouldn't be feeling ill. Um, but when you change directions, you do. So the reason why you end up feeling so sick in that game is because uh, you are changing directions a lot. And something that I haven't hit on yet, I will hit on in a little bit, is that you don't have any chassis around you. So let's put a pin in that because I didn't quite get to the point of finishing explaining how the actual like effect works.
Sure.
So just going back, simplifying down, your ear measures acceleration. Your eyes are being told that your body is moving. Your eyes are being told that your body is not just moving, but that your body is accelerating. Right? You're floating through the cavern. You hit the wall. You do a flip turn. You push off. All of these things, your body is like, I should be receiving accelerometer data from my ear, and I'm not. My ear is telling me I'm sitting still, and my eyes are telling me that I'm moving. And so what's happening is that these two signals, they're coming together. And the way that your brain deals with signals is that it's all electrochemical, right? And it's all about thresholds. So what happens is those two signals come in and they're basically supposed to, I'm drastically simplifying here, but they're basically supposed to cancel out. You're supposed to get a motion signal from your eye, and a motion signal from your ear, an acceleration signal from your eye, and an acceleration signal from your ear. They're supposed to hit and they're supposed to cancel out. And if they don't, you get a little buildup. And then you get another one and they don't cancel out, and it builds up a little more. And it builds up a little more. And like every moment that you're accelerating, your eyes are saying one thing, your ears are saying another thing. This chemical imbalance builds up. And at a certain point, it goes over this threshold, and your body goes, something is wrong. And here's the really, really amazing part. Why? I'm going to ask this to you, hypothetically. Why would your body make you want to vomit if it thinks that you're not moving? Like, why does your body care that your eyes are saying that you're moving and your ears are not?
I kind of cheated and read something about this, but I think it's the example that I heard was like food, like bad food poisoning.
Yeah. So, like, you're right. So, evolutionarily speaking, like our, evolutionary ancestors, the only time that biological entities in the natural world experience this is when they've been poisoned. Because poison, a lot of neurotoxins, cause your nerves to malfunction, right? And the evolutionary purpose of that is that when your nerves malfunction, your muscles don't work, your eyes don't work, you get discoordinated, you fall over, you either stop being able to chase or stop being able to run. Either way, you're screwed, right? So your body, when your body gets this, like, eyes saying one thing, ears saying another thing, your body goes like, oh no, I've been poisoned, void. It's probably, I ate something bad, blah, let's get rid of it.
Yep.
So, let's go back to Echo Arena. I was talking about this thing with chassis, right? So, there are circumstances where you are in a situation all the time where your eyes are saying one thing and your ears are saying the other, right? Like, a lot of people are capable of reading in a car without throwing up.
Right.
So this is because we've been sitting in cars our whole lives. And when you do something for your whole life, it's incredible the amount of, it's called neuroplasticity, right? Like, you can be hardwired for something and just kind of like smack that down, especially if you start doing it at a young enough age. And most of us have been, reading or playing games or, watching DVDs in cars, whatever, for most of our lives. So we have programming that we've laid over the top of this really, really old hardware programming. Remember what I was talking about? There's wetware, there's software, there's hardware. Right? So we have sort of like this wetware that says, this is what's supposed to happen. And then we have this like software of our own brains, which is the training that we lay over the top of that. Then you plug this hardware in on top, the goggles, and if you do it right, if you design right, you can exploit this training. So, like, a good example is like a jetpack game. There was a jetpack game that came out on the Gear right when the Gear came out. I can't remember the name of it. I'm going to look it up because it's great.
Sure. Yeah, because actually there was something I had written down while you were talking. that touches on what you're about to say. I remember getting very motion sick when I was a kid. I would read like Harry Potter or whatever in the car, and I remember getting really, really motion sick. And now I never get motion sick when I read in the car. So I guess, neuroplasticity and my brain change. I was gonna, follow up and say, if that's possible with VR. It seems like a more extreme experience, and it seems like it would be harder to adapt to. But I think it's possible.
It's totally possible. It's absolutely totally possible. I mean, like, I would put money that kids who are 6 or 7 right now, who start playing VR at a young age, who ignore the health warning that everybody's saying to not play till you're 13.
Right.
Those kids are not going to get motion sick from VR, right? And the way to show this is that actually there's a thing called lock-in syndrome, which people used to get a lot with traditional TV-based video games. Same exact thing, right? And what this was is that people would be locked in on their screen. They basically would tune out everything else that was around them, and then they would just be focused. They would basically fake their way into feeling presence. They would be so tuned into their game that their brain would be like, oh my God, I'm running around. Why don't I feel like I'm running around? And they would get sick. Right. And to this day, there are some people, usually people who didn't grow up playing video games, that like can't play first-person shooters. They like get motion sick from playing Halo. So the thing is, though, the jetpack game I was talking about is called Omega Agent. And in Omega Agent, you have a very minimal chassis around you. So what this does is it gives you a local frame of reference, right? You have some dials. You have these bars in front of you. You kind of have like a gun mounted. And all of these things, they fill up about 30 or 40% of your field of vision, and they don't move. They're static. And so my interpretation of this, and I found that I was able to play this game extensively without getting motion sick. And there is a lot of motion. You're up, you're down, you're forward.
Yep.
It's jetpack game, But because you have this frame of reference, sort of like there's a spectrum, right? And on one end of the spectrum, you're flying around like Superman, completely free, like you are in Echo Arena. Mm-hmm. Nothing around you. And on the other end, you're in a completely sealed tube, right? Like you're in an airplane with no windows. And if you're in an airplane with no windows, if your only frame of reference is the local stuff, you can't see the motion at all. And because you can't see it, and your ear doesn't feel it, to your brain it doesn't exist. Of course, on the other side, if you're flying around like Superman, you're getting the worst possible situation for your brain. Your eyes are like, I'm moving, and your ears are like, you're not. And there's a spectrum back and forth between. And sort of on the low end, you have like this jetpack game. And on the other end, you have sort of like a more traditional space fighter game or airplane game. And then like even further up, you could imagine a game where it's like you're inside of a box, and we even like designed the game around like your reference to the outside world is like a computer screen, right? Because we grew up playing video games, we have trained ourselves not to feel ill from motion on screens. So this is something that I'm surprised we haven't seen in design yet.
Oh yeah, like screens in the game. Yeah. I was gonna say I can corroborate the point of reference helping, because I actually played a hang glider game at the Seattle VR meetup. Shout out to the Seattle VR meetup. And flying around, jumping down mountains, going fast, changing directions. But I think you could see whatever the part of the hang glider is that you kind of hold on to, and maybe like your hands. And that made all the difference, because I didn't get sick playing that game.
Yeah, you're talking about Glider Island by
I think so.
Joey Sipos.
Uh-huh.
Big fan. I really like that game. I feel like it does a great job doing exactly this. It gives you just enough frame of reference to allow you to have this flying experience,
right?
Which for most people doesn't make them sick. And so this brings up a really interesting problem and difficulty around the design of these kinds of games. This stuff varies, right? There's not one thing that applies to everybody. There isn't even really like a norm yet. So like where I was talking about with Halo, most people who are video game players can play first-person shooters without getting sick. And actually even just most normal people in our society are used to enough of moving around, either from being in cars or watching movies or whatever, they're used to sort of like this certain level of mixed signals that you can design around that as a game. Like as a game designer making stuff for TV. But we don't have that training. We don't know where these levels are in VR yet. So you really have to be sensitive. You really have to. I basically design everything around zero acceleration, and a lot of people are doing this as well, which is why you see the teleportation locomotion mechanic being used so much.
Right.
Because it's just a cheat. It just allows you to have people move with zero acceleration.
It's a cheap solution, yeah.
It's wonderful.
So, just kind of a fun question for you. Have you seen any or heard any horror stories? Because I imagine the Echo Arena is probably dealing with some issues with... I have no idea. Maybe I'm wrong. I don't know like what percentage of the population suffers from what degree of motion sickness. I'm sure there's data out there. But I would imagine that it's affecting like adoption of their game. And other games like it are probably running into issues and complaints.
I haven't heard any horror stories, but I think that we're about to start seeing. I'm gonna coin a phrase. I think we're about to start seeing a sort of like Gibsonian competitiveness, and I'm referencing, Gibson, the author of Neuromancer and the creator of the term cyberpunk, William Gibson.
Yeah.
And in a lot of his work, they talk about how interfacing with the machine. And he sort of treats the machine as like this sort of like, grand, almost spiritual plane, like the internet. He actually even also created the term the Matrix. So like when people jack into the Matrix, they're like plugging into the internet. And those people who are capable of tolerating sort of like the brutality of the machine get the edge in their culture, right? And so I think that we are just starting to see this, where like people who want to play Echo Arena, they're going to be like, yeah, I'm so hardcore, I can play Echo Arena for 10 hours and only vomit 3 times, and just like the place where we actually are seeing this, there is one specific competitive sport that this is already an issue. I don't know if you follow it all, but competitive drone racing.
No.
There's this thing, it's called first-person drone racing. And these people, they put on goggles. They look like VR goggles, but they're not. Right? VR goggles track the motion of your head, track your position through space nowadays. These goggles are not that at all. They're just goggles with they literally have an antenna that sticks out of the top that receives an analog signal from a camera on their drone. And it just feeds it to them directly. Doesn't matter where they turn their head, they just see straight. And so these guys, they are giving themselves like the worst possible. They're beyond the Superman point, right? Like they're just getting pure raw acceleration, and they're going around and around and around in circles and up and through like these loops and these crazy hoops and obstacles. And they're doing it for hours at a time, and they're all about winning. They're super competitive. So you know what these guys do? This is the most cyberpunk thing happening in the real world today.
What do they do?
They take motion sickness drugs. They take Dramamine so that they can compete.
That's wild.
They drug themselves so that they can better commune with the machine. It's like literally William Gibson's wet dream. Like this is what he was talking about in like 1983.
That's crazy. Because I was thinking just how competitive esports is already, and how, there's like only really people only in certain ages are even really competitive, and then just adding this other element on top of it. It's really crazy to think about that.
Yeah, but I think that's where we're going. I think that the nature of competition has always been that there's the level of this difficult thing, whether it's mentally difficult or physically difficult or whatever. There's some level that most people can get to. Then there's a level that some other people can get to. But the people that we're really interested in watching are the ones that blow both of those out of the water, right? Like, you don't care about a moderately good cyclist. No, you want to see the guy that's 5 times better than the next 5 world's greatest cyclists combined, right?
Right. That's what athleticism is kind of all about, I guess. Or it ends up being about that on an entertainment level anyway. So that we kind of touched on this already, but I was gonna ask, like, where do you see future VR going? Like, is there going to be? I think you've already kind of maybe said no to this question, but I was gonna ask if, like, will software? Is this a pure software problem? Can you just solve this with software?
I'm so glad you asked that because I completely forgot about one of the coolest things going on here. No, I don't. I don't think you can solve this with software. I think that the best we can do with software is like what I would consider to be like an early days workaround. So let me explain what I'm talking about with that. So if you look at early video games, a lot of them are really great. At least the ones that we still talk about and care about and think about today. But they are all a product of what the technology was capable of. People designed their games, they wrote narratives, they backed into the mechanics, and they backed into their game from what they could do, not the other way around. And somewhere around the mid-90s, that stopped being the case for us. We got to a point where anything you wanted to do, if you had the budget, if you had the time, you could do it. You could make basically any game you want. Graphical fidelity might go up or down, but it was all possible. And we're now back. We've been thrown back in time to a place where we literally have this hard limit. If you want a game that's going to be accessible to everybody, you have to back into it. You know, you can't have a game where you're flying around like Superman. So you need to come up with games that have mechanics that fit within what's possible, right? Something I'm surprised that we haven't seen yet is actually a Dragon Ball Z fighting game. Because in Dragon Ball Z, like they're like basically like like teleporting all around each other while like fighting. Seems like a perfect match.
Yeah, or just standing there and yelling.
Yeah, that would be a great game because there's no acceleration when you're just yelling for 3 episodes.
Yep.
But just like in the 90s in the late 80s, when video games started to get hot, the hardware community was like, boom, there's money in this. We're going to throw everything we have at better graphics, better sound processors, higher fidelity screens. I mean, look at controllers. Like, we went from tiny little boxes with one joystick on it to like 15 joysticks and buttons in like the span of 7 years. So this is happening already in VR with hardware. There are 2 different approaches that I have heard about being followed to solve this problem with hardware. And both of them have to do with, 3 approaches. So the first one is the one that a lot of people have talked about. I think this one, honestly, is kind of lame. People have started using treadmills. And treadmills are pretty cool, but they're so expensive, they're so big, they're so cumbersome. I have a rule with my VR, which is that like I really think that most people want to use VR today when they're on an airplane. When they're in a situation where they can't escape, where they're stuck sitting someplace, that's when they want to put on goggles and float away into some other place. So if you come up with a solution that can only be used in an arcade, that's cool. I love the idea of arcades. I think that's going to be big. I think it's going to be important. But it's not like it's not the Game Boy effect, or like the Angry Birds effect, where it's like literally every single person can play this anywhere they go, anywhere they go.
Yeah, it's not the least common denominator or whatever. Yeah.
Boom, exactly. So there are these 2 other technologies that I'm interested in. Both of them surround direct stimulation of your vestibular canals. And so one of the approaches is mechanical, where people are attaching essentially like small buzzers. And one of the approaches is electrical, where people are trying to zap either the fluid. I don't know exactly how this works, but either the fluid or the nerves themselves.
I heard about this. It's like a small amount of voltage.
Yeah. And then, of course, there's the approach that nobody is really working on yet, except maybe Palmer Luckey. We don't really know.
Yeah.
Lucky. Which is just like...
Jacking into the Matrix, yeah.
Yeah, man. I mean, if the problem is that you're getting a signal from your eyes and not from your ears, like, why don't we just let's just bypass both and send the signal straight to your brain?
I'll let you be the guinea pig for that one, my friend. Or Palmer Luckey maybe is guinea pigging himself, but it'll be a while until I trust jacking in directly.
He's probably just got a backup clone that he's testing on,
Right. So, I want to leave some time to talk about. I know you had a project you were working on, that you wanted to talk about, and it sounds really cool. So I want to leave some time for that. But I do have one more question that I often ask people on here, and I want to ask you. And it's just, what are you most excited about in VR?
Oh man. Um,
And VR means VR, XR, AR. It's like the whole thing.
so yeah, I can tell you the thing that I'm most excited about. Uh, I actually wrote an article about a year and a half ago called the uh, VR pop culture reading list, and it just is a list of literally every single book that I could find that has to do with VR and AR. And about 4 years ago, when I decided that I was going to jump into this, I took it upon myself as a project to read all of it, to just read every single book that had to do with VR, every single book that had to do with AR, just consume the entire pop culture zeitgeist. I also watched all of the shows, the movies, the comic books. I just absorbed it all.
Nice.
And the one that really, really stuck out is this book called Rainbow's End by an author named Werner Vinge. This book is actually so good that when I finished all my VR stuff, I then went and consumed everything that he ever wrote. But Rainbow's End is this incredible book. It is basically Rainbow's End is to AR what Ready Player One is to VR. It depicts a 15 minutes into the future world where AR has become the dominant technology, where screens are gone and everybody is either wearing glasses or contacts or neural inlays or direct jacks into their brain, and everybody is walking around seeing their own flavor of reality. They have, the way that I like to describe it is like if you like Star Wars, you walk around in Star Wars world all the time. You like Harry Potter, you're walking around in Harry Potter world all the time. And actually, the book literally references Terry Pratchett's Discworld as a main aspect of the story, right? That one of the main groups is like a borderline religious entity that is obsessed with Discworld. Anyway, this technology that he describes, where everybody is sort of like inside of their own skinned reality, and we sort of have these shared spaces where we agree upon setting the rules of a reality within some confine, like within a room or a sporting complex or a library, whatever it is. He calls this consensual realities. And to me, this is the most believable place that we are going. VR, spectacular, and I love it, but I think that VR is akin to hardcore gaming, and AR is more akin to like that lowest common denominator thing, that Angry Birds. I don't really believe in a future where every single person in the world is walking around, isolated, or is spending all of their time locked in their room. There's definitely going to be some people that do that. Just like there are tons and tons of people that spend their time isolated right now, locked in a room staring at a screen. But the vast majority of the people, the vast majority of the time, want to be interacting with humans and technology simultaneously. And so this idea of consensual realities is like sort of the binding tech, the binding glue that brings us all together. I'm very, very excited about it. And there's so much. But what it really comes down to for me is the idea that right now people are walking around and they're staring at their phones. People used to ask me when the cardboard first came out, like, do you really think we're gonna, put phones 2 inches from our face all the time? And I was like, have you looked around?
Yeah.
But with AR, the magic is that you don't have to. We're not going to go to a place where we need less digital, where we're going to be less reliant on digital information. We're only going to a place where it's more. Mm-hmm. So AR is so exciting to me because it means that we can have both. Mm-hmm. We can be looking up information and having stuff fed to us, and we can be making eye contact with other human beings at the same time. And that, I think, is the fusion of both worlds that we need. We need the internet to leak back out into reality because we've put everything that matters to us inside of these little black boxes, and it's dehumanized us.
Right. It's not the best human-computer interaction. Okay. So before we started recording, you were talking to me about Strudel Doodle, and I want you to talk a little bit about that.
Yeah. So Strudel Doodle is a project that I work on in sort of in my free time. There's a ton of incredible stuff that I'm working on at Digital Domain, which unfortunately I'm not allowed to talk about at all. So Strudel Doodle is like my one sort of like escape public project. It's a 3D modeling and world building tool. I originally built it for the Vive, but it's coming out next week for ARKit. You can find out more about it at strudeldoodle.com. It's spelled with two O's and two O's. So STROODLEDOODLE. Um, and yeah, I mean, it was basically created as a response to my love and also my frustration with Tilt Brush. Tilt Brush is magnificent, but the things that you make in it can't exist in the real world. It's very, very difficult to create things that have volume. You could not take something that you make in Tilt Brush and have it 3D printed, for example. And up until relatively recently, it was very, very difficult to bring things from Tilt Brush into even Unity or Unreal to use them as characters, in another game. So I built this thing, Strudel Doodle. It is, to my mind, the simplest possible, easiest to get in, lowest barrier to entry way of building stuff in 3D. People who have never been in VR before can put on a headset, have this thing in their hands, not be told anything, build their first ever 3D model, and share it to Sketchfab, and then straight to their Facebook in less than 15 minutes.
It sounds awesome.
And now people are going to be able to do that at the bus stop, at their office, on their coffee table. The ARKit build it's pretty neat. I'm not going to lie. I used it for the first time, actually myself, to successfully build an entire model, and I was just like squealing with joy.
So we will need iPhone then for the mobile version.
For now, AR Core is sort of like dropping officially in a couple of months. Adoption on that is going to be a little bit slower. Mm-hmm. Apple pulled this amazing strategic thing where they actually started designing their phones for AR 3 years ago. ARKit is cool. AR Core is actually going to be better, but it's not here yet. So yeah, for today, you need to have an iPhone.
Okay, well, I have an Oculus, so I'll definitely be checking it out on there. Well, that sounds awesome. I'm going to check that out, and then I'm also going to look up that if you could repeat the that article that you wrote with the resources on XR.
Sure. It's called the. Hold on, let me just look it up.
Sure. Yeah. So I'm going to check it out. I'll put a link to it in the description of whatever you're listening to this on.
It's called the Virtual Reality in Pop Culture Reading List.
Okay.
And actually, fortuitously, I just published, at the behest of my friend Drew Stone, I just published the follow-up, which is the Virtual Reality in Pop Culture Viewing List, which is movies and TV shows, literally last night. So now both of those are available. They each have about 20 things in it that you can check out. Yeah.
Sweet. That's awesome. So, all right. Well, this has been a real pleasure, Eric. I really, really appreciate you coming on. Is there any, do you want to share your Twitter, or is there any other thing that people should follow you on?
Yeah, Twitter is the best. Follow me on Twitter. It's Eric, ERIC, _ Neuman, NEUMAN. I'm also really, really easy to find on Facebook and YouTube. Just search for me, Eric Neuman.
Okay. Thank you so much. Thanks for coming on.
Thank you. My pleasure. Have me back anytime. I could talk about this stuff all day, as you can tell.
Hey guys, just wanted to say thank you for listening, and if you enjoyed that, if you learned something about VR, simulator sickness, and you enjoyed the conversation, please go click like, follow, subscribe on Twitter, YouTube, Facebook, all under the name Synthetic Native. So please do that. Leave a comment or a question or a suggestion if there's somebody you'd like me to talk to next or some content you'd like me to cover. We're going to be covering a lot of XR-related content, VR, AR, XR, and we'll continue to do that. But we're also open to covering content on general human-computer interaction, advanced user interface concepts, how machine learning and AI are going to affect the way that humans interact with technology, and just how technology is shaping your life. That's really what this podcast and this content is supposed to be about. So just let me know if there's anything in that realm that you're interested in. And yeah, thanks again so much for listening, and we'll see you next time.